Okay, so let's work a little bit more with the phase shift. You'll notice again in this case, what we have is negative pi over 4. So we're expecting a phase shift, right, to the right, pi over 4. What this means in practice is all our x values, we're going to be adding pi over 4 to them. So again, how do we demonstrate this? Manipulate your core data, right? So for a cosine graph, it all starts with our quadrant, right? Our quadrantal angles. Cosine is 1, 0, negative 1, 0, and 1. And so since we're doing a phase shift to the right, pi over 4, that means I'm going to add pi over 4 to all of my x values, right? And so our new data set, we'll do the math here in a little bit, right? This is still 1, 0, negative 1, 0, and 1, but I now have to take 0 and add pi over 4 to it. Of course, that's just going to give us pi over 4. I have to take pi over 2 and add pi over 4. Well, again, we're adding fractions, so this is 4 pi over 2 plus, 2 pi over 4, right, plus pi over 4. So we end up getting 3 pi over 4 when we add. When I add pi over 2 to this, we end up with 3 pi over 2. When I take 3 pi over 2 and add pi over 4, this is basically 2 over 2 is 6 pi over 4 plus pi over 4. That's 7 pi over 4, right? And then if we take 2 pi and add pi over 4, that's 8 pi over 4 plus pi over 4, which is 9 pi over 4. So hopefully that, way back when, I think 3.1, when we were talking about coterminal angles and moving things around, I said let's do the fraction work. Hopefully it's paying off now. But these all these points on our normal cosine graph are shifted this way on this graph. And you'll notice that the period hasn't changed, right? Because if we took 9 pi over 4 and subtracted pi over 4, we get 2 pi. So we still have the normal period of 2 pi. It's just shifted to the right, pi over 4. So graphing this, here's what this graph is going to look like, right? So again, we're bouncing between 1 and negative 1. And then my new data point, right, we're starting at pi over 4. And then we have 3 pi over 4. And then we have 3 pi over 2. And then we have 7 pi over 4. And then we have 9 pi over 4. And so our graph, right, starts at 1, starts at 1, right, because we're pi over 4, 1, 3 pi over 4, 0, right, 3 pi over 2, negative 1, 9 pi over 4, 7 pi over 4, 0, and then 9 pi over 4, and we're back at 1. So here would be the graph of the cosine that's been shifted over, right? This would be cosine of x minus pi over 4. To see the shift, right, what I'd have to do, excuse me, is, let me kind of sneak this in here. Between pi over 4 and 3 pi over 4, well, there's our pi over 2, right? And then what we end up having somewhere in here is pi, and right, 3 pi over 2, and then right in between here, I hope I got everything correct, right? 3 pi over 2, 7 pi over 4, right? So 2 pi would be somewhere right in here, right? And there's 3 pi over 2. So I might be a little bit off with my theme, but we start off with 1, and then we have a 0, and then we have a minus 1, right? And then we have a 0, and then we have a 1. And I think I'm a little off, but there's in blue what our cosine graph is. And so you can see everything's been shifted over pi over 4, right? Shifted over pi over 4, shifted over pi over 4. So the whole graph, right, the period hasn't changed. We've just shifted the graph. And sorry, hopefully in blue I nailed some things down okay. But I think, yeah, we'd be 0 at that point, right? I just think I'm off. My scale is off just a hair, just with regard to that. Okay, so there you have it. Right, there's our shift. Sine of x pi over 4. Again, we're shifting to the right, pi over 4. So we basically going to be doing all this math, except our y values, will be the cosine value. So how about I just, well, I'll do it point by point. So our normal sine graph, right, starts at 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and then 2 pi 0. So what's our new data? I've already done the math, right? So we're going to basically be adding pi over 4 to all these guys. So that would be pi over 4. This would be 3 pi over 4, 3 pi over 2, 7 pi over 4, and 9 pi over 4, right? I think I did all my math right. Let's just double check it, okay? And then 0, 1, 0, negative 1, 0. So I'm going to do it this way, so that way I don't get my, we know normal circumstances, we have pi over 2, we have pi, we have 3 pi over 2, and we have 2 pi, right? And then of course halfway between this would be pi over 4, pi, 3 pi over 4, right? 7 pi over 4, oops, 5 pi over 4, excuse me, and 7 pi over 4. So I just took the big quadrant angles, and then if I cut those in half, right, I get all the pi over 4 stuff. And I did that just so we can, I'm not screwing myself up like I did there. So in red, right, my new graph is pi over 4, 0, right, 3 pi over 4, 1, let's put a negative 1 down there, 3 pi over 2, right, which would be here, right, 0, and then we have 7 pi over 4, negative 1, I guess I'm a little off, and then we have 0. So here's our new graph. I think I can almost see, right, pi over 2, I started getting a little smaller, so I kind of screwed up the scale there. But there's basically our graph of the sine of x pi over 4. All right, and so what about the sine graph? Well, a normal sine graph, right, does all this action, right, like so. Oops, I think I screwed up. 9 pi, I know what I did. 9 pi over 4 would be out here. So that's why things were looking a little scrunched up. And so the sine graph would do this guy right here. So in blue, right, you can see that everything has been shifted over, right? All the data has been shifted over pi over 4 units. Okay, so that's, you can see that the phase shift basically occurring, right? So there's our first round. Again, it does get a little crazy because we're really manipulating our scaling along our x-axis. You even saw me struggle with it a little bit. We'll just, again, practice makes perfect as we get better, but hopefully you are seeing that action, this phase shift action. How about I cut to another video where I do this a couple more times and we practice doing some math, right? And we practice using our scaling, and yeah, I'll even try to be better. All right, talk to you guys in a little bit.